Algebra 1, Lesson 95. We are combining our rational expressions with unlike denominators. Now, we've looked at this before a little bit, especially with those like denominators, but we did look at some that had different denominators, and we had to find those common denominators. So in this, we'll be adding and subtracting them without common denominators. And of course, your first goal with anything, because these are fractions, we have to find common denominators. So let's look at this one first. Now, overall, this lesson, it's not super complicated. It just takes some time with some of these different rational expressions. So I'll show you a few examples. I'm not going to be able to show you all of them in this video. Now, in the first thing we need to do is factor. So we're okay with the first fraction. That would stay the same because there's nothing to factor. But the second one, we could factor into 9 over x minus 5 times x plus 3. Since this is a simple quadratic, we need to multiply to negative 15, add to a negative 2, which means we can kind of see that these denominators are similar, but that this denominator, our first one, is missing a factor of x minus 5. Now remember, with our fractions, if we had something like 3 over 5 plus let's say 7 over 10. We could find common denominators by saying that, well, this is 3 over 5 plus 7 over 2 times 5, which means that this first one is missing a factor of 2, so I would multiply it by that factor of 2 over 2. And I have to multiply it by that 2 over 2 because I can't change the fraction, but I can multiply it by 1 when it's in the form of 2 over 2. And that's what we're going to do with this one. Since it's missing a factor of x minus 5, I'm going to multiply by a factor of x minus 5 in numerator and denominator, meaning that I'm not actually changing the fraction because x minus 5 over x minus 5 is really just 1. So I can expand and simplify here. So I'm going to expand this 3 to everything, and so I get 3x minus 15. And then since they now have common denominators, I can subtract 9 and have that over x minus 5 times x plus 3, which means I can now just combine like terms here and get 3x minus 24 over x minus 5 times x plus 3. Now, there's one last step that we can do, and that is to factor it again. The denominator is factored, but the numerator we can actually factor here, just in case it has a common factor to the denominator. So we would say 3 times x minus 8. And in this case, it doesn't have a common denominator. That's okay, so we'll just leave it as it is. So let's just look at a few more examples. So in this one, that first fraction is going to stay the same, 5 over x minus 2 plus 6 over, and I'm going to factor this to x minus 2 times x plus 1, meaning our first fraction is missing a factor of x plus 1. So I'll take x plus 1 over x plus 1. Now I have common denominators, so we have x plus 1 times x minus 2, that's common now, and I can now expand this 5 to everything, so I have 5x plus 5, and then I'm going to add to that my 6. So I have 5x plus 11 over x plus 1 times x minus 2. Nothing to factor here, so we leave it as is. Now there is one more part of this, and these are rational expressions, which mean there's a variable in the denominator, and I have to tell what that cannot equal. Now remember that the denominator cannot equal 0, which means my x plus 1 times x minus 2 can't equal 0. So I have to figure out what would make it that way and exclude those values, which means if I'm multiplying two things together and it equals 0, one of them has to be 0. So at least this one has to be 0, or this one has to be 0. So I would say x plus 1 equals 0. That would mean that x is negative 1. X minus 2 is 0, so x would be 2. So I exclude those values. All right, let's look at another one here. And in this one, we're going to have to do a couple things, it looks like, because I need to factor both of the denominators. So in the first one, I'm going to do 2x, And I'm going to factor out, I'm going to do this up here so we can do it in one step. I'm going to factor out a 4 first, and I get x squared minus 49, which means that I can factor that x squared minus 49 into 4 times x minus 7 times x plus 7. And then for the second one, I'm going to do 12x over x, well, it needs to multiply to negative 56 and add to 1, which means I'm going to do x plus 8 times x minus 7. All right, now it looks like both of these two fractions are missing something. In the first one, well, it looks like we're going to have a factor of 4, x minus 7, x plus 7, and x plus 8 in order to have common denominators, which means in the first one, I am missing x plus 8. And in the second one, then I would be missing a 4. Actually, I'm going to simplify this first, and I'm going to simplify the 2 and the 4 here to have just a factor of 2 here. So I'm going to actually multiply by 2 and an x plus 7. Okay? So when I do that, let's expand out and simplify. Now we have this common denominator of 2 times x plus 8 times x minus 7 times x plus 7. And I'm going to expand out my numerators and combine them as much as possible. So this x goes to x and the 8, so I get x squared plus 8x. And the 12x goes to the 2 times x plus 7. Now I am going to expand that to say this is actually 2x plus 14. So that 12x is going to create a 24x squared, so expanding out 12x times 2x, and 12x times 14, let's see, that is, I believe, 168x. Which means really what I need to do is combine like terms in the numerator to say I have 25x squared and 176x over 2 times x plus 8 times x minus 7 times x plus 7. It looks like that numerator not really going to help me simplify anything, because the only thing that can be factored out is an x, which means it wouldn't be able to be factored by the denominator. But one last thing, we need to exclude some values. So we say x cannot be negative 8 because that would make this factor 0. Can't be 7 because it would make this factor 0. And it can't be negative 7 because it would make this factor 0. And so we exclude those values. So you can see how it can get pretty complicated by how much you have to multiply by, but if you keep it organized, you can make sense of it. Let's just try a couple more. Okay, and let's see, I'm going to do the top one on here. And I'm going to say 6x squared. I can, and then that x squared minus 16, I can factor that term into 6x squared over x plus 4 times x minus 4, plus we have this x plus 1 over 2 times x minus 4, which means on the first one I am missing a factor. I'm going to be missing a factor of 2 over 2, and on the second one I'm going to be missing a factor of x plus 4 over x plus 4. Which means I'm going to have this denominator of 2 times x minus 4 times x plus 4. And in the numerator, I'm going to get a 12x squared from the first term. And I am going to get, well, that's a binomial times a binomial. So I am going to get x squared plus 5x plus 4. And you can check that out yourself by multiplying it out with FOIL or the box method or whatever you desire. And then I can factor here, or I can add up my like terms to get 13x squared plus 5x plus 4 over my 2 times x minus 4 times x plus 4. I don't believe that 13x squared plus 5x plus 4 can be factored. You can check that, make sure that we're not missing anything, but just for sake of time, we're going to go on and say x cannot be 4 or negative 4. But of course you can try and factor that 13x squared plus 5x plus 4. All right, I am going to show you one more example here, And let's see which one. I think this is a good one to look at. So I'm going to make some space for myself here. And we're going to look at this first one together. All right, so here I'm going to factor, and I'm going to get negative 35 over, and I'm going to factor out a negative 7 to get an x plus 8, or sorry, an x minus 8. Let me change that really quick. An x minus 8 here. So negative 35 over negative 7 times x minus 8. And then plus, I'm going to factor out a negative 2 to get 3x plus 1, just in case I can factor anything. And I'm going to say I have an x minus 8 and an x plus 2, which means in this first one, I'm going to be missing a factor of x plus 2 over x plus 2. And in the second one, I'm going to be missing a factor of negative 7, which means I now have this denominator of negative 7 times x minus 8 times x plus 2. And in the numerator, I get a negative 35x minus 70. And then on this one here, I'm going to get, let's see, we have really a negative 6x times negative 7, so plus 42x. And then negative 2 times negative 7, so plus 14. Which means I can combine some like terms here, and I get 7x. And then minus, let's see, 56 over negative 7 times x minus 8 times x plus 2. Now I can see that I might be able to factor a little bit more, so I'm going to factor the numerator to get 7 times x minus 8, which means this negative 7 and the x minus 8 factors in the numerator and denominator can be simplified here. Okay, which means I have, I'm going to write it up here, 1 over, and I have a negative x plus 2, so I have a negative x minus 2, which means that is my simplified version, much, much simpler, and I can say x cannot be a negative 2. Okay? All right. So I'm just going to show you a couple more examples that you can try out on your own. These ones need to be added together. Think about how really we're just going to have to multiply by 230 minus w over 230 minus w for the second one, and 230 plus w over 230 plus w for the first one in order to get common denominators. Unfortunately, there's no better way to do it. And similarly for this one, but there is some simplifying that can happen. All right, well, I hope that helps for your homework and for studying.